Hello everyone. Whenever you did the monohybrid crosses homework, and then I gave you the marks and you marked it, I asked you if there are any questions that you wanted me to explain. So there's a couple here that people have picked out. The first one that people mentioned was question 5, part 5 here, V there, which is Roman numeral 5. Okay, if we look back at this in the previous page, basically we've worked out the ratio that we expected was a 3-to-1 ratio, 3 normal to 1 vestigial. But whenever you counted it, you got 16 normal and 4, which is actually a 4-to-1 ratio, not what we expected. Now, question 5 says, suggest why the actual 4-to-1 and predicted 3-to-1 ratio may not always be the same. Well, in this case, we've only got a small sample. We've only got a sample of 20, which in genetics is a very small sample. Normally, in genetics, if you want reliable results, you'd be looking at 100, 200, more than that. So the fact that we've got a small sample means that we're not going to get very reliable results, and that means that we would not always get the expected ratio. If you have a look at these figures, so here we've got 6 small samples, and there's the one at the top that we mentioned there, okay, which is roughly, that's a 4-to-1 ratio. The next one, that's a 3-to-1 ratio. That looks like a 4-to-1 ratio, and that's a 4-to-1 ratio. That's almost a 1-to-1 ratio. And that's almost a 1-to-1 ratio. So there's quite a lot of variation there. But if we add up all of these figures here, we get 90. And if we add up all of these figures here, we get 30. So if we'd had just one big sample with 90 in it, so if we had 90 to 30, and that's normal and that's vestigial, that simplifies to 3-to-1 ratio. So if you take a small sample, any of these, chances are you're not going to end up with the expected or the predicted ratio because it's a small sample. You know that if in a family, the ratio of males to females should work out 1-to-1. It's a 50-50 chance each time a child is born whether it's going to be male or female. So if there's 4 children in a family, laws of average say there should be 2 males and 2 females. But yeah, I'm sure you know plenty of families where that's not the case. But if you were to look at the population of Northern Ireland, it's more or less half male, half female, give or take the odd decimal place. So the answer there is because the sample is very small. The next question that other people wanted me to explain was this one here. Now, to explain that, we need to sort of just go back over the first bit there. So this widow's peak, the fact that somebody's hair sort of comes to a peak there, is a genetically inherited condition. It's quite normal. And they're saying the allele for that condition is dominant. So big W, I'll get a smaller pen here, big W represents the peak, small w, I suppose we could say, maybe if we stick with the terminology, so they had widow's peak present, and then small w, widow's peak absent. And for part B, it said use a Punnett square to show the possible genotypes of children from 2 heterozygous parents. So heterozygous means that the genotype consists of 2 different alleles. So that must mean they both must have a big W and a small w. So that's your Punnett square. And because we're using a W, you need to be very careful how you write your answers to make sure that there is a distinct difference between the large and the small w's. So those 4 are our offspring. Now, the question C says, what proportion of the offspring are homozygous? Homozygous, homo means the same. So homozygous means both alleles are the same. So they're both 2 big W's and they're both 2 little W's. So that's 2 out of 4. So that simplifies to a half. So half or 50% of the children are homozygous. What is the probability of these heterozygous parents' next child being a girl with a widow's peak? Now, at this case, I've said in my answers, ignore the fact that the question says girl, just work out the probability of having a child with a widow's peak. So, child with a widow's peak. Widow's peak, there are, if I use a different colour, widow's peak, you need to have a big W. So there's 1, 2, 3. Widow's peak to 1 where they don't have a widow's peak. So what are the chances of having a child with widow's peak? 3/4 or 75%. Now, at that stage, we hadn't worked out probability of having a boy or a girl. If we were to go back now and answer that question properly, at the time in the mark scheme I said, look, just consider that it's a child, not the fact that it's a girl. But now that we've looked at how sex is inherited and we know that the probability of getting a girl is a half, what's the probability of it being a girl and widow's peak? Well, you know in maths, if your probability of getting heads is a half, and then the probability of getting heads the second time is a half. If you want to get, so if you toss a coin twice, probability of getting heads followed by another heads is a half times a half. So in this case, probability of getting a girl is a half, and we want the girl to have a widow's peak. So that would be widow's peak. So what's the probability of that? 3/8. So that would be the answer if you were answering that fully. But in the mark scheme I said, look, we're just going to ignore the fact that it says girl there, because at that stage we hadn't looked at how sex is inherited. If you put 3/8, that's fine. You can give yourself a mark. I didn't expect you to do it, but if you worked it all out, you got 3/8, that's fine. Okay. And if you want to leave me a message to say, well, actually, I got that, so add an extra mark to my total, I'll do that. So hopefully everything makes sense there. If you're still stuck, drop me a private message and I'll get back to you. Bye.